Hi there, I'm Kyle Bratcher. I am the primary author for UR-87, Adversarial Patch Attack and Deep Learning-Based Remote Sensing Object Detection Model. As an introduction, deep learning systems have replaced many traditional approaches within machine vision, and these new object detection systems based on deep learning are becoming incredibly prevalent and critical in many important applications that uh, are important. However, these systems are still vulnerable to many different attacks. So by developing these attacks, and investigating vulnerabilities, we can develop more protections against these attacks with critical applications, such as remote sensing. What kind of vulnerabilities are these systems vulnerable to? Well, primarily targeted noise is developed to disrupt how these deep learning based systems see the world. So for the example, this is a PGD attack where the noise affects how the deep learning system classifies this image of a panda to a system of a gibbon. In order to develop this in a real world environment, we can target this noise to a specific adversarial patch that can be placed within an image. By generating a patch, applying it to our data set within remote sensing, and then feeding that through a modern object detector such as YOLO V8, we can attempt to minimize given loss functions and use backpropagation to train the patch that will then maximize its effect against the object detector's performance with a targeted amount of noise within the patch. By evaluating the mean average precision score, which is just a general evaluation of how well the detector uh, uh, the expected bounding box compares to the predicted bounding box, we can measure object performance before and after this generated patch. So for a map 50 score, uh, before the attack, our object detector had a score of 0.91, which indicates very good performance. However, after the generated patch attack, it has a new map 50 score of 0.15, which demonstrates that even with the even though the object detector is very good with the patch, it becomes much less viable. In conclusion, these systems are the standard for object detection and remain important, but even modern object detection systems are still vulnerable to adversarial attacks. Developing these attacks and investigating these vulnerabilities in critical fields, such as remote sensing, is crucial to protecting them in the future.